So let's do some examples here. We have a difference times a sum. I recognize this as the difference of squares. Just to recap here, the difference of squares is if we take a sum times a difference, we end up with the difference of their squares, a squared minus b squared. So you're going to take whatever's in the first term minus whatever's in the second term, each of those squared. So this one, since we have a difference times a sum, this is going to be x squared minus 25. And I can kind of jump to that without the intermediate steps. Of course, I could have done this the long way. I could have done x times x, 5x, a negative 5x, and a negative 25. Canceled the two middle terms that I would get here. Alright, here we have a 4x and a 3y, 4x and a 3y. One of them's a sum, one of them's a difference. So again, we have a difference of squares sort of pattern happening. So what I'm going to end up doing is I'm going to take the first term squared. Well, I have to remember when I square this, I have to square each of the individual parts. So 4 squared times x squared, so that's 16x squared, minus, I have to, when I square this one, I get 9y squared. And again, I could have done this the long way as well, but I'm trying to practice my difference of squares, so that's why I'm doing it this way. Alright, on this one we have a 2x and a 6. A 2x and a 6. One of them is a sum, one of them is a difference. So that means, again, I have the difference of squares. So I'm going to get 4x squared, that's the first term squared, minus 36, that's the second term squared.